Students, we were discussing the numericals from your section waves. Okay, we have discussed two sums. Now I will move on to question number 3. Alright, so I will dictate the question, I will explain it, then I will move on to the solution. Your question number 3 is like this: find the phase difference of 2 points 1 meter apart lying on a ray if the wavelength is 2 meter. Alright, so students, I have discussed the phase difference in the class many times. Okay, so what is the question given? That you have to find out the phase difference of 2 points. That means the value of x is given, they are 1 meter apart, and the value of wavelength, that is your lambda part, is also given. Okay, so let's write the formula for finding the phase difference. So your phase difference, okay, phase difference theta equals to 2 pi x by lambda. This is the formula for the phase difference, isn't it? Just recall the phase difference classes. So now I will put the values because x and lambda are to be found out from the question. X value is 1 and his lambda value is 2. So 2 pi into 1 by 2. Okay. So we will be left with only pi radian. Don't forget to write this unit, students. For phase difference theta, your unit will be radian. Okay. So that is it. Your question is done. Answer is done. Very small sum. Just you have to recall the formula. Then your answer will be done. Alright. Now, yes. So this was your easy sum. Now I will move to question number 4. Let's see what's there in the question number 4. The question number 4 is: find the displacement from the position of equilibrium of a point lying at a distance x equal to lambda by 6. X equal to lambda by 6 from the source of oscillations for the moment small t equals to big T by 3. Okay, I'm just tabulating the data. Alright, and the amplitude of oscillation is, that means your A value is given as 20 into 10 to the power minus 2 meter. Okay, what you have to find out, students, you have to find out the displacement from the position of the equilibrium of a point lying at a distance of this x equals to lambda by 6 from the source of the oscillations for the moment t equals to big T by 3, and the amplitude's value is also given. Okay, so students, for this you have to recall the formulas for the displacement of a progressive wave that we have discussed in the class. See how I am choosing the formula. So I have to choose one formula, students, that means the equation of the motion, where I will able to put this x value, that means x by x and lambda, this combining this x by lambda, I can able to write one equation. Okay, so keeping this in mind, and what I'm getting, your small t and big T. So by this small t and big T, that means if small t is divided by big T, so keeping all these things in mind. Okay, and what is the main, and the next value is given, the value of A is given. Okay, so keeping all these things in mind, that what I am getting from the question itself, I am writing one formula. See students, what formula I am picking it up. So I am choosing this y equals to A sine 2 pi small t by big T minus 2 pi x by lambda. Okay, so see, You can ask me that why I have chosen this formula, that means equation of this motion. See, from this A part I am getting, not any worry regarding this A part, the amplitude part. From this 2 pi is constant, so I require this small t by big T, one magnitude for this small t by big T. Whether I am getting, yes I am getting from the question, small t by big T, I can put this value, that means 1 by 3. Let's move to the next step. That is your 2 pi constant, it's constant, leave it. So x by lambda, yes I'm getting also, x by lambda will be your 1 by 6. Okay, so let's all this magnitude, all these values in our equation. Let's see what happens. So students, keeping all these things in mind, I have chosen this formula where I will get all the values that I require. And from where will I get the values? From the question. From the question all these data are being provided. Yes, so I'm writing it. So 20 into, writing this value for the amplitude, into 10 to the power minus 2, a sine within bracket 2 pi big T by 3 into T. I will explain this, don't worry. Let me write it first. Solve this sum. First term is done. Next I'm moving to 2 pi into lambda by 6 into lambda. Okay. Yes, now I will come to the solution. That why I have written this. 2 pi was there only from the beginning. So for t, I can write t by 3. That means for small t, I can write big T by 3. See this thing? So I've written it here only, big T by 3. And I had previously big T in the denominator. So I've written it here. Okay. Same way for this. For x, what I can write? Lambda by 6. See, I've written lambda by 6. And I had from the beginning lambda in the denominator. So I will keep it as like this only. That means lambda in my denominator. So just now what will I do? Just I will reduce it. So 20 into 10 to the power minus 2 sine. Now see what terms can get cancelled. This t with t will get cancelled, 2, 6 and all. Okay. Okay, so finally we'll get pi by 3. Okay. So your final answer is this. So just write the value. You will get 17.32 into 10 to the power minus 2 meter.